In this video, we're going to talk about how C# handles date and time values. We're also going to look at a new kind of expression that we haven't seen before called an object creation expression. And we're going to look at, very briefly, at a new kind of type that we haven't seen before called an enumerated type. But before I get into all of that, I want to ask you a question. And that question is, what day of the week was January 1st, 2015? Well, you might not know off the top of your head, but it should be pretty easy to consult a calendar and find out that it was a Thursday. All right, seems straightforward. What day of the week was February 29th, 1900? Well, that's a trick question. There was no February 29th, 1900 because of Pope Gregory, and also because of Julius Caesar. So Julius Caesar came up with this great idea that there should be a thing called a leap year, right? And that on certain years we should insert an extra day into February 29th, right? And that this would happen every 4 years. It turned out that Julius Caesar was unaware of the fact that though this corrects a large error in the calendar, it introduces a much more subtle error of about 3 days every 400 years or so. By the time of Pope Gregory, who lived in the 1500s, that error had accumulated so much in the calendar that Easter was now weeks wrong, right? And Pope Gregory decided to do something about this, right? So he said that from now on, what we should do is there will be no leap year, there will be no leap day inserted on leap years that end in 00, right? Leap years that are evenly divisible by 100, unless they are evenly divisible by 400, right? So that takes care of the 3 days every 400 years problem, right? So 1900 was not a leap year. 2000 was, because 1900 is divisible by 100, but not by 400. 2000 is divisible by 400. So there was no February 29th, 1900 because of the Gregorian form to the Julian calendar. That did cause some problems. Old timers among you may remember there was a program called Lotus 1-2-3, which is a spreadsheet before the days of Microsoft Excel. And Lotus 1-2-3 had a bug in it where it did treat 1900 as having a February 29th. And so when Excel was created, in order to be compatible with Lotus 1-2-3, Excel introduced the same bug. And so there's now all of this crazy date-time handling code in Excel and in the Windows operating system to account for the fact that some Lotus 1-2-3 documents have this strange belief that, that February 29th, 1900 was a day that existed. It's all very complicated. All right, so that was a trick question. So you might be suspicious of this question. What day of the week was the 5th of October, 1582? Well, it turns out that Thursday, the 4th of October, 1582, was followed by Friday, the 15th of October, right? Because in 1582, that was when Pope Gregory said, Easter is wrong by 11 days. I'm just going to remove 11 days from the middle of October and call it good, right? So just as there was no February 29th, 1900, there was no 5th of October in 1582 anywhere that paid attention to Pope Gregory. But not every country in the world was Catholic. Britain did not adopt this reform until 1752. Russia did not adopt this reform until 1918, which is why the Ukrainians have Christmas at a different time than everybody else. But that's an entirely another story. My point is, it is super complicated to handle dates and times in any kind of reasonable way because it is so embedded in facts about our culture and our history. So C# gives us a very, very simplified version of what a date and a time is. It does know that there was no February 29th, 1900, but it completely ignores all other aspects of the Gregorian reform and the fact that the calendar changed over history and all of that. So let's, now that I've finished that little historical lesson there, let's jump into some code and see how C# handles dates and times. So I'm going to start this program up here. step into it. You'll see that once again I've added system.globalization to our list of using directives up here, because later on I'm going to be formatting dates and times according to the rules of different countries. So the first thing to notice is that there is a type called datetime. And datetime has a static property. So far we've seen static methods like console writeLine and string.format. And we've seen instance properties like string.length, but we haven't seen a static property yet. So this is a property that is associated with a particular type. And the property is, what time is it right now? Now, my personal opinion, just to have a little aside here, is this actually shouldn't be a property, because it's not something like the length or the color or something like that of a thing. Right? Really, this should be a method called getCurrentTime. But it's not. This is a minor design flaw in the design of the .NET runtime, and there you go. We're just stuck with it now. So anyway, we say datetime time is equal to datetime.now. And what did we get out of it? We got 4:10 p.m. on the 26th of February 2015. So you now know exactly when I shot this video. All right. So we could use IntelliSense to find out that there's all kinds of good stuff on this date time thing. There is a property called day. Right? There's a property called day of week. There's a property called second. And there's a property called ticks. And let's take a look at each of those in turn. So let's start with day. If we hover over it, we can see that it's 26. It's an integer. That kind of makes sense, right? It's the 26th of February. What about day of week? Well, if we step over this thing, we hover over that, we can see day of week is Thursday. Is this a string? Now this is a subtle point. You notice there are no quotation marks around that Thursday. This is actually a special kind of type called an enumerated type. And an enumerated type is a type that is like an integer, right, in that its values are numbers, but each number in it is associated with a specific name, and you almost always refer to those numbers by their names, right? And we could say here, I'll just stop this program momentarily, right? We could say day of week, right? That's the type. And then if we wanted to assign it a value, right, we wouldn't assign it the value 1, let's say. That would be an error, right? It would tell us, cannot implicitly convert type int to system.dayofweek. An explicit conversion exists. Are you missing a cast? Right? So it's telling us that, you remember the cast operator that we talked before, you are allowed to say, no, really, I mean this number 1 to be a day of week. And that would work, but that's kind of weird, right? Normally what you would do is you would just say day of week dot, and then IntelliSense gives you all of the options: Friday, Monday, Saturday, Sunday, Thursday, Tuesday, Wednesday. You'll notice that IntelliSense lists them in alphabetical order, which is maybe a little bit odd. Maybe it should be listing them in numerical order, but IntelliSense always lists things in alphabetical order, so there you go. Right. So we could say day of week dot Saturday, and then this would provide the integer value that was associated with Saturday in this enumerated type. All right, we won't worry about enumerated types too much more in this course, but they do pop up, and so I thought it might be interesting to talk about them. So let's keep moving on here. Start this up again. Second. All right, well, that is 9. So apparently it was 9 seconds past the minute when I just fetched the time here. Yeah, it's 4:13 and 9 seconds p.m. Now, what's this one? Ticks. Let's step over that and see. Holy goodness, that is an enormous number. What on earth is this thing? The ticks are as follows. Suppose you imagined starting a stopwatch that ticked 10 million times per second. You started it on midnight on January 1st, the year 1 AD. You assumed that the Gregorian calendar was in effect through that entire period from the year 1 AD through now, right? That there were no leap seconds that were introduced to keep our atomic clocks aligned with the motion of the Earth and all of that. This is the number of times that clock would have ticked up to now. Right? So it's an absolutely enormous number. Now you might think, oh, this allows us to keep track of seconds to the 10 millionth of a second, right? That's very, very accurate. If you actually look carefully at this number, and it's difficult to do it here because it's in decimal notation, but if you got several different ticks and you subtracted them, you compared them, you would discover that this value actually only updates every 64th of a second, right? It updates as though it were ticking 10 million times per second, but it only actually updates it every 64th of a second. So the facility is there for more accurate clocks if we ever want to build them. And there is a type in C# called stopwatch, which we're not going to cover in this course, that allows you to time things down to the millionth or the billionth of a second. But we're not going to talk about that. All right, moving on. We have this time. So the 26th of February, 2015, 4:13 in the afternoon. And suppose I try to add 1.5 hours to that thing and then print out the result. Well, if we look at what printed out, it says the 26th of February, 2015, 4:13 and 9 seconds in the afternoon. And I thought we added 1.5 hours. And if you've been paying attention, you might have noticed that we've seen this problem before. When we had string.toUpper, it did not change the value of the variable. It returned a new string that had the desired property. And the same is true here. Right? This guy does not change the value of time. It does not add 1.5 hours to time. Rather, this thing produces a new time, which adds 1.5 hours to the receiver of the method. Right? So if we put that value in this variable, then we can see, now this is the 26th of February, 2015, 5:43 and 9 seconds in the afternoon. It's 1.5 hours later. We could also add a negative amount of time if we wanted to, right? We could say negative 1.5 here, and that would be 1.5 hours ago. All right. What if we want to represent a specific date and time? So, for example, my birthday, the 30th of November, 1972. You now know how old I am. This is a syntax that we have not seen before. This is called an object creation expression. An object creation expression creates a new value of a particular type in those circumstances where you need to provide information about what the new value is. The syntax is, it's just like a method call. It's got a type name, right? Unlike a method call, it doesn't have a dot and then the name of the method. Also, unlike a method call, it has the word new before it. This kind of makes some sense. We're making a new thing. Like a method call, it has a list of arguments that are inside parentheses. So if we were to use IntelliSense, which we will do right here, we can see that there are 12 different ways to construct a date time. We can give it the year, the month, and the day. We can give it a count of ticks. Lots of different things we can do. We can give it the year, the month, the day, the hour, the minute, the second, the millisecond, the kind of calendar that we're using, and so on. Lots of different ways to do these things. There's 12 different ways to create a date time. I'm using the simplest possible one here of just the year, the month, and the day. Right? So if we run this thing, step over that, we can see that birthday now contains the 30th of November, 1972. You'll notice that it says midnight, 12 a.m. We did not give it any time. Right? In C#, a date and a time always go together. You might say, well, what if you want to represent just a time and no date? In that case, the traditional thing to do is to represent the time as on the day January 1st, 1 AD, sort of the 0 day of this calendar system. We won't worry about that too much. We're going to look at this date, which is a date without a time, or rather the time is midnight. All right. We could ask, what's the difference between two dates? We know that we can subtract integers from integers and decimals from decimals and doubles from doubles. It turns out we can also subtract dates from dates. But what should that be, right? the difference between two dates isn't a date, right? It's not like February 1st minus January 2nd is December 31st. I mean, what sense does that make, right? So this is actually something else. This is a thing called a time span. And so if we step over this, we can see that age is a system.timespan. For the first time, we have seen a type in C# that does not really print out anything that's that sensible when you hover over it. But we'll find out that we can dig into this thing pretty easily. Now, one way we could do that is we can just point down here at this arrow, and more information will pop up about what this thing is, right? So this particular time span has 15,428 days and 16 hours and so on. But let's take a look at this in the debugger here, right? So this time span has a property called days, right? Like I said, 15,428 days. 33 seconds, right? Well, that seems odd. 15,428 days is not 33 seconds, right? What's going on here is we have taken the difference between now, right, and my birthday, right? Now was some time that had some number of seconds past the current minute. My birthday was exactly midnight, right? And the seconds portion of that difference is represented by the seconds field in the time span, right? If you want to know how many total seconds that is, then you, of course, use total seconds, and it looks like, holy goodness, I am 1.3 billion seconds old. In fact, I am almost exactly 1 1/3 billion seconds old. I'm pretty old. All right, you can also compare date times, as you might imagine. You can say birthday is less than date time now, and the dates that are farther in the past are less than the dates that are more in the future. So plainly, now is more in the future than my birthday back in 1972 was. Right? So this thing is true. You can also compare time spans in a similar way. Right? 10 days is less time than 20 days. And just as you can take two dates and subtract them to produce a time span, you can also take a date and a time span, add them together to produce a new date, right? So subtraction works the way you would expect, right? It's a little bit odd that subtracting two things doesn't produce a third of that thing. When you subtract two ints, you get an int. You subtract two doubles, you get a double. You subtract two dates, you get a time span, right? But it works out because the addition works out, right? You add a date and a time span, you get a date. You can't add, and if you add two time spans together, then you get a time span. All right, what about formatting dates? We saw in the last video that there were lots of different ways to format currencies. We formatted a currency using the culture of Great Britain. We can do the same thing with a date, right? You probably noticed that when I displayed that date before of my birthday, it said 11/30/1972, which is the American way to do it. I grew up in Canada. The American way is still confusing and weird to me, even though I've been here for 20 years. The British and the Canadians do it in the much more sensible way, like this. Right? So if we get the culture info for Great Britain, and then there's a special method of a special overload of toString on date times that take a culture info. So we can simply say, here is the culture associated with Britain. Give me this time formatted this way. And we point at this thing. Then you can see it says 26/02/2015, 16/19/08. Right? So not only did we get the date in the sensible order of days, then months, then years, we also got the time formatted in the 24-hour clock, which is much more common in Great Britain than it is in the United States. And finally, there is a way to use our method string.format to format dates and times in any way that you can possibly conceive of. So once again, recall that string.format in the format string takes curly braces and then a 0 and then a colon and then some information about how you want things formatted. And it will replace all of that with whatever is in this argument here. Right? So we have this argument, this time. Right? The 26th of February. And if we then call string.format, this says I want years, I want months, I want days, hours, minutes, hours and minutes with a colon between them. And then what is TT? Well, let's just step over this thing and find out. We pointed that and says, this is 2015, so the year in 4 digits. The month, Feb, the month in 3 letters, MMM, right? Then the day, 26. Then the hour in 2 digits, HH. Then the minute in 2 digits after a colon. And then TT means put AM or PM here, right, depending on which one you want. Something to watch out for, a very common mistake is to say YYYY MM, right, and use the lowercase m, which is, as you can see over here, minutes, right? And then you accidentally get years, minutes, and days. Happens all the time. I've made that mistake myself. Like I said in the previous video, there is no good way to deduce what these formatting strings are. If you go onto the internet and do a web search for C# formatting strings, you will find lots and lots of different examples. Summing up, C# datetime handling does not reflect historical changes in the calendar. There have been lots of them. There are people who study this extensively and who have created calendar libraries in C# and in other languages that do reflect those historical changes, but this is not one of them. You can use date time and you can use time span to represent dates and times and elapsed times, respectively. Date time and time span are both immutable types, right? So if you call an add hours method on one of them, it does not change the variable, it doesn't change the receiver. It returns you a new value that you should then assign to a variable or use in some other way. Right? And be careful to not confuse seconds with total seconds. Be careful to not confuse months with minutes. There are lots and lots of ways to make mistakes here. So just be careful when you're writing code that involves manipulating dates and times.